This short video will cover addition polymers, and we'll look at repeat units and monomers and how to make a polymer. To start off with, let's take a monomer which will have a carbon-carbon double bond. So there's our carbon-carbon double bond. Let's just put 4 random groups onto this. So we'll have a couple of hydrogens and then we'll put a couple of silly groups on. So one can be a daisy and the other can be a smiley face. So there's our monomer. Now one thing that you'll find quite useful is to draw our monomer out slightly differently. So rather than showing the correct geometry, we know that it's trigonal planar around the carbon-carbon double bond, let's turn our monomer into what looks a little bit more like the letter H, and we'll put our groups on again. So we had 2 and the daisy and the smiley face. So what happens when we make the polymer? Obviously we've got lots and lots and lots, hundreds if not thousands of these. So let's line up a series of our monomers, so they're all going to go side by side, and when the polymer is made, what happens is that the double bonds will all break and bonds will form between those carbons. Also, if we're showing part of a chain, it's important to remember that this goes on off into the horizon. So now to identify the repeat unit, well, we can see I'm just putting a boundary around there, and hopefully you can see the next thing that comes along is another one of those and then another one of those. So the repeat unit that I've identified below there. Sometimes you'll see brackets drawn around that. I could just have easily have picked this as my repeat unit again, so the next thing that comes along is another one of those and another one of those. With that being my repeat unit, hopefully we can see that's the same thing. Occasionally you might be asked to identify 2 or 3 repeat units. So maybe starting here, so that section there shows 2 repeat units. So to the notes then, I've started with the second example, which is PVC. So we have chloroethene here. So the repeat unit of the polymer, remember we'll draw our monomer out. Like the letter H, remember I've broken that double bond, so they're now just a single bond between those carbons. And the other important feature is that we've got these trailing bonds. Sometimes you might show them as dotted lines. If we just show them as solid lines, maybe useful just to pop some brackets around so we show that it's going off into the distance. To show the balanced equation for the formation of this polymer, so we start off with the monomer and let's show the repeat unit of the polymer. It's asking for a balanced equation, so we want n lots of our monomer, which will give us n of the repeating unit. To go the other way around from the repeat unit to the monomer, so we have a look at the repeat unit. So this is basically our molecule but without the double bond, so let's draw that again. You can see it's not complete yet, so I've removed those trailing bonds and all that's left for me to put in is the carbon-carbon double bond there. Got some more examples in this table, and we're either going from the monomer to the repeat unit or vice versa. So in the first example we have a propene molecule. To draw the repeat unit, remember, just draw the monomer out again without the double bond, making sure you give it the trailing bonds going off. So there's our repeat unit, and it's asking for the IUPAC name of the polymer. Well, if the monomer is propene, then we simply have polypropene. Exactly the same process with the next one. So we'll draw our monomer. It's a nitrile group this time. Again, lose the double bond, trailing bonds. It's the other way around in this next example. So we want to just show the repeat unit again. So with the 4 fluorines, this time put the double bond back in. The monomer is tetrafluoroethene, and so this polymer is just polytetrafluoroethene. You may have come across PTFE before, so more commonly known as Teflon, and this provides a non-stick surface, so it's widely available in commercial products such as saucepans, irons, hair straighteners, etc. More of the same in the next example. So there we're going from styrene to polystyrene. Note that we've broken the double bond again, we've got the trailing bond, so there's our repeat unit. So you've probably heard of polystyrene. So this is used as low density packaging, and your house will be covered with it on a birthday or Christmas. For the final example, we're going from the repeat unit back to the monomer. So there's our repeat unit. Let's draw that out again. So you can see I've lost the trailing bonds. I just need to put the double bond in between those 2 carbons. Let's see if we can name the monomer that we've got. So you might be thinking that's dichloroethene, which is not a bad guess. Just need to remember we need to number those chlorines. So the monomer is 1,1-dichloroethene. So for the name of the polymer, we just take that and put a poly in front.